All right, welcome to our next chapter. In chapter 9, what we're going to be looking at is the whole category of what are called conic sections. You guys know a little bit of conic sections already. Something like a circle is already a conic section, and then a parabola, although we're going to be looking at slightly altered parabolas and more in depth with them. Then we're also going to be looking at the ellipse and the hyperbola. So you guys have some familiarity with this, but not a ton. So day one, what we're going to be looking at in day one is going to be specifically the circle, and we're not actually going to be looking too much at an ellipse, but we will look at a parabola. But we're looking at different types of parabolas in day one. So all of the conic sections that we talk about are the result of intersections of a single plane and a double napped cone. So here you have the image for what a circle, ellipse, parabola, and hyperbola look like. So in all of these cases, when we talk about a conic section, we talk about this double napped cone. And all these images just come from slicing that cone with a plane. So if I slice that plane in a way where it's parallel to the base, I form a circle. If I slice that cone in a way that it's not exactly parallel to the base, a lot of times I hit that ellipse. For a parabola, I'm slicing that right through the base. So there you can see that U-shaped parabola. And a hyperbola, it's sort of like two parabolas that don't touch each other. That's when you're slicing up and down with that plane. Don't worry about necessarily remembering that double napped cone or something like that. Be more concerned with knowing the shapes of those, and circle, ellipse, parabola, you already know, but hyperbola, that's new. Three other conic sections that we can talk about. If we slice that plane right through the point where those two cones meet, we just get a point. So when you guys have seen points on a plane, or points anywhere really, that was sort of a conic section. If I slice right along those two cones, I form a line. And if I slice along that point, going through both cones, I'm going to get two intersecting lines. So when we talked in the beginning of the year about lines, intersecting lines, and the equations for those, we were working in that realm of conic sections. Okay, so that's the geometric way. So you guys were able to see the picture to sort of help guide that mentality. But we're going to look at the algebraic way. It's a lot more structured. There's a lot more work we can do with it. And you guys love the work. So all equations of conic sections are in the form of ax squared. This is going to be a little bit long, plus bxy plus cy squared plus dx plus ey plus f equals 0. By putting in different coefficients for a, b, c, d, e, and f, we can write equations of different conic sections. So for instance, you guys are used to things like y equals mx plus b. You remember that as being a line. Well, in y equals mx plus b, you have an x term, you have a y term, and you have a constant. So that means in that line, A, B, and C are all 0. So we'll sort of look at throughout the chapter how this equation determines what type of conic section that we have. And there's going to be a really good chart for it. We'll refer to the book to sort of help guide that as well. They have a good diagram for it. So first one that we're going to talk about, totally not new, circles. When we talk about a circle, I know you know what a circle is, but really what it is the collection of points that are all equidistant from a single point called the center of the circle. Now, that's not new to you. You guys know that, but we're going to sort of use that theme of equidistance to talk about things like parabola, hyperbola, ellipses. The equation of a circle is in the form x minus h squared plus y minus k squared is equal to r squared, where h comma k is the center of the circle, and r is the radius. That whole concept of h comma k is going to follow us throughout this chapter, although not with everything will we have what we would call a radius. All right, so then a parabola. Yes, I know that that parabola is like that U-shaped graph, and a lot of you guys relate it to a quadratic function, although you can have a parabola that is a non-function in the first place, and that's what we're sort of going to be looking at more. So when we talk about the parabola, it's the set of all points that are equidistant, starting off sort of that same way, the set of all points that are equidistant from a fixed line That fixed line is called the directrix. Sort of a cool name, directrix. And a fixed point. And that fixed point is called the focus. Those two vocab words, directrix, focus, they're going to follow us throughout 9.1, 9.2, and 9.3. And in some cases, the way that we deal with them are a little bit different. All parabolas are in one of two forms. They're either in the form of x minus h squared equals 4p times y minus k, or they're in the form of y minus k squared equals 4p times x minus h. Notice all that happened here is that those binomials switched places. Those binomials switching places is going to tell us what type of parabola we have. Two things about this: p cannot be equal to 0, and h comma k represents the center. Again, that's not new. That's the same thing as when we're dealing with the circle. Sorry, it's not going to be called the center, though, because this is a parabola, Mr. Davis. It's the vertex. All right, easy fix. Vertex, not center. Center for a circle. All right, so moving on, we're going to talk about that first form. That first form, x minus h squared, is equal to 4p times y minus k. So this is the parabola that you guys are used to. You're used to something that's like y equals x squared plus 3x minus 5. And maybe you'd complete the square. So maybe you're used to it as like y equals 4 times x minus 2 squared plus 1. It's all stuff that you've seen. This is the parabola that opens either upwards or downwards. And the way that you determine in this form whether or not it's upwards or downwards is based upon what is the p-value. So if p is greater than 0, then our parabola is going to be opening up, this parabola that we're used to. And if p is less than 0, the parabola opens downward. Two things that you guys are totally familiar with. What's important to keep in mind here is, again, you have that background knowledge of a parabola. X squared, you guys know that the x squared is always meant it's a quadratic function, so it's opening up or opening down. And that's going to be important to remember because the next form, where we switch that and have y minus k squared is equal to 4p times x minus h, well, this parabola opens either to the left or to the right. So when we're memorizing these formulas and using these formulas, keep in mind that the one that's x squared is the one that you're used to. You're always done x squared. We never really did the y squared type things. And that's because when you graph something that's going to open to the left or open to the right, it's going to end up being a non-function. But it is still a parabola. So in this case, if p is greater than 0, the parabola opens to the right, which means it's going to look like that. And if p is less than 0, the parabola opens to the left. All right, so then we got to talk about, like, if p is positive, we know it opens either to the up or right, and if p is negative, it's either opening to the left or down. But what exactly is the p-value, and what does it mean in terms of our graph? So in both forms, whether it's the x minus h form or the y minus k form, the value of p indicates what is called the focal length. Focal length is going to be like one of the most important things to remember throughout this chapter, other than all of the formulas. But focal length, when we're talking about that, that's telling us the distance from the focus to the vertex and the distance from the vertex to the directrix. So keep in mind, these are our two other vocab words that I had said are going to be important ones. And that's sort of the idea of why. That p-value, it tells us how far the vertex of our parabola is from what we call as the focus, and how far it is from the line that we call a directrix. All right, and then just to sort of give you an image of what these look like. So here, if I have a parabola that opens up or a parabola that opens down. So we're working with these ones that are x minus h squared, the parabolas we're used to. We have a lot of things going on in this graph, but the important things, the focus. The focus is always going to be inside the parabola. It's contained in it. And what you remember is, if I'm starting at the vertex, the focus is going to be p units away from the vertex. So if your parabola opens up, and you know that p is 2, you know that you must be going up 2. It can't be left, right, or down, because the focus has to be inside the parabola. If your parabola is opening downwards, so you know p is negative, let's say it's negative 4, you're not going to move to the left 4, up 4, or right 4 from the vertex, because it has to be within the parabola. So we're going to move down 4. The directrix, you do the opposite of that. So where the focus is always going to be inside the parabola, the directrix is going to be outside of it. And the directrix is an entire line. So in this case, I think we said that p was 2. So we said, okay, if I had the vertex and I went up 2, I get the focus. If I'm at the vertex and I go down 2, I'm going to get the line of the directrix. Or here we said negative 4. If I go down 4, I get the focus. If I go up 4, I get the directrix. And then we have parabolas that open to the left and to the right. It's the same mentality. The focus has to be within that parabola. If p is positive, that means I know it's opening to the right because we're working with the y minus k squared form. So if this was, let's say that I knew that p was 2. I'm going to start at that vertex, and this time I'll go to the right 2 because the parabola opens to the right. I'll go to the left 2 to get the directrix. Notice the directrix in this case is a vertical line, as opposed to in the previous one where it was a horizontal line. And then on the right, you have a parabola that opens to the left, so we know that the p-value is negative. And let's say it was negative 1. I start at that vertex, I go to the left 1, and I get the focus. I go to the right 1, I get the directrix. Now, we're going to stop there. The 5 examples we'll do in class, or the 5 slides of examples we'll do in class. What you need to make sure that you know is, what is focal length? What is a directrix? what are the equations for circle and for parabola. And then if you need to rewatch the video, jot down some notes, jot down where you have questions, and we'll go over those right at the beginning of class. Thank you.